Hi there, David DiBiase here. This is a longer version of the presentation that Anthony Robinson and I prepared for the AutoCarto 2022 conference. The conference theme was Ethics in Mapping, Integrity, Inclusion, and Empathy. Conference presentations were limited to 15 minutes, so we had to omit a lot of detail. This recorded version is a bit longer and more complete. The title of the talk is meant as a humble homage to Brian Harley. In 1991, he visited Penn State and presented his talk, Can There Be a Cartographic Ethics?, in the Department of Geography's Venerable Coffee Hour series. Brian kindly agreed to publish the paper in Cartographic Perspectives, the upstart journal I then served as editor. Here's what we plan to discuss in the next 20 minutes or so. We'll identify and characterize master's programs branded as Spatial, Geospatial, or Geographic data science in August through September 2022. We'll assess the prevalence of ethics-related content in academic program and course descriptions. We'll propose an understatement factor to help account for mismatches between course descriptions and actual course activities. We'll visualize and discuss variations among academic programs, and we'll describe Penn State's approach to ethics education. The idea of spatial data science has been around for a little while. The first time I heard of it, as I recall, was when Luke Anslin observed in this 2016 blog post that GI science is morphing into spatial data science. Given the attention data science has attracted in recent years, it's not surprising that GI science people would think about its relationship to their work. Then in 2021, Alex Singleton and Dania Ribas-Bell of the University of Liverpool published their very polite manifesto, Geographic Data Science. Their argument is essentially that geographers and GIS people have a lot to learn from data science, and that data scientists have a lot to learn from them. Ethics is centrally important to their vision. Geographical data science would, they write, closely align with core critical and ethical principles that have been advanced within geography and, in particular, the subdisciplinary field of GI science. Ethics has been a hot topic of sorts in the geospatial community at least since Harley published Deconstructing the Map in 1989. Will Craig proposed the GIS Code of Ethics in 1993, and John Pickles' Ground Truth appeared in 1995. We may be in another ethics moment now. Ethical Geo and the Benchmark Initiative published their Locus Charter within the past year. The AAG hosted a geoethics webinar series, and Nelson, Goodchild, and Wright issued their clarion call for accelerating ethics, empathy, and equity in geographic information science this summer. Especially given the theme of the AutoCarto 2022 conference, it seems both timely and worthwhile to assess the extent to which ethical issues are included in geographic data science curricula at this stage. Let's start with Penn State. Penn State's Department of Geography developed its Master of Science in Spatial Data Science program to provide a path for distance learners that highlights geospatial programming, spatial statistics, and the design of new solutions to spatial analysis problems. The program anticipates increased demand for application area knowledge within data science, and it helps position our online programs to have a future beyond GIS in its more traditional meaning and approach. Ethics education is a required element of all our graduate programs. Formal training in ethics research ethics has been mandatory at Penn State and most other higher education institutions since the America Competes Act was signed into law in 2007. That legislation requires any student who receives NSF funds must obtain training in the responsible conduct of research. Institutions are responsible for determining both the content and the delivery method of their training. Students pursuing Penn State's Master of GIS or Master of Science in Spatial Data Science comply by successfully completing either a no-cost 12-hour online workshop called Responsible Scholarship and Professional Practice, or the 3-credit graduate seminar Geography 581, Spatial Data Science Ethics. Both compliance and ethics, we should note, are concerned with standards of behavior, but compliance is concerned only with minimum standards. In practice, we observe many peer programs do what's needed to comply, but seldom include domain-specific content. For this project, our first task was to identify master's programs branded as Spatial or Geospatial or Geographic Data Science. In August through September 2022, we searched the web on a variety of keywords in English, French, Spanish, and German. We found 13 academic master's degree program sites that provided descriptions of required and optional courses. One of those clusters, perhaps not surprisingly, is in England, Ireland, Scotland, and Germany. Here's the Liverpool program, Birkbeck College, and Universitat Münster. Another cluster is in the US. Here's Penn State, University of Kentucky, University of Illinois, and Temple University. In addition to the 13 graduate programs we assessed, the web map also locates 8 other comparable programs and 2 undergraduate programs. We don't claim that this inventory is exhaustive, only that we conducted it methodically and with care. To assess the prevalence of ethics content in the 13 target programs we found, we replicated a method described in this 2021 article in PeerJ. Jeffrey Oliver and Torbett McNeil examined major requirements and corresponding course descriptions to assess the alignment of 18 undergraduate data science programs with the National Academies of Sciences, Engineering, and Medicine's framework for data science education. That framework identifies 10 key concepts involved in developing data acumen, as they put it. Oliver and McNeil developed rubrics based on the 10 concepts to score published course descriptions on a 4-point scale using content analysis. The 10 key concepts are arrayed on the y-axis of the graph shown at right. The x-axis is a set of 10 4-point scales. The dots on the number line represent scores associated with each of the 18 undergraduate programs. The hollow circles, like this one, represent means of the program scores on each of the 10 concepts. The 10th concept shown is ethical problem solving. The relatively low scores on that concept led the authors to conclude that current data science undergraduate programs may not deliver sufficient context in terms of ethics considerations necessary for appropriate data science applications. Here is Oliver and McNeil's scoring rubric for the ethical problem-solving criterion. We adopted this rubric to assess the possible outcomes of ethics education in the 13 spatial or geographic data science master's programs we found. As a first step, we used part of Oliver and McNeil's rubric to assess the ethics content in our own master's program in spatial data science. Here's the scored rubric we used to assess Penn State's own program. It documents, the scored rubric includes URLs for program and course descriptions, both direct links and permalinks that memorialize the content we found during our assessment. It documents courses that address each of the 5 rubric criteria, if available, as well as relevant quotations found in the course descriptions. Also note that just 2 courses and 1 instructor-led workshop account for all the scores shown on this rubric, and only 7 courses out of nearly 30 mention ethics-related issues in their course descriptions. What does that say about the prevalence of ethical issues in our curriculum? Based on a parallel effort to map our instructors' perceptions of their course's learning objectives, we know that our course descriptions understate the prevalence of ethics content in our curriculum. Over the next few slides, we'll explain how we developed an understatement factor to account for the difference. About a year ago, our colleague Brandy Gartner designed a project to characterize and align our curricula with programmatic learning objectives. The upper table here outlines those 9 competency areas, including ethics. Brandy asked instructors to rank the level at which their courses address each competency: 1 for introductory, 2 for practice, 3 for mastery, and X for competencies that didn't apply. 18 instructors participated in the exercise, providing rankings for 29 courses. This spreadsheet compares instructors' responses to the Curriculum Mapping Project questionnaire, they're shown in blue, to our assessment of ethics-related content in the descriptions of those courses, shown in red. The totals shown in blue reflect instructors' sense that 22 of 29 of our courses, 77%, include some ethics-related content. By contrast, only 7 of those 29 courses, just 24%, include ethics topics in their formal descriptions. In other words, the pervasiveness of ethics education in our course descriptions may be understated by as much as a factor of 3. That understatement factor probably applies, more or less, to all the academic programs we've assessed in this study. We'll return to this point in our conclusion. This table lists the 13 master's programs we found and assessed. Note the URL here. That links to an open Google Sheet that includes all 13 of our rubric scores. Let's take a quick look at that sheet. The 13 rubrics appear as tabs in the sheet. Let's take a look at a few of them. Illinois, for instance. Illinois has no mentions of ethics issues in its course descriptions. But we can't conclude that that means that there's no ethics-related content in those courses. Kentucky's Digital Mapping Masters is included since it embodies the spirit of spatial data science, even if it doesn't adopt that name. Consistent with Singleton and Arribas-Bell's article, Liverpool's course and program descriptions are replete with ethics-related content. Same with Munster, though we had to translate module descriptions from German. Christian Knopf at Munster confirmed that Google's translation was faithful enough. Temple's Professional Science Master's program in Geospatial Data Science is the only one we found with a required course on professionalism and ethics in geospatial data science. Program leader Lee Hackadorian tells us that the National Association of Professional Masters Programs requires such courses. Finally, USC also has no mention of ethics content in its course descriptions. However, it's at a disadvantage because course descriptions in both their program site and university catalog are extremely brief, typically just one sentence. We're quite sure that the understatement phenomenon applies especially here. Here we compare Oliver and McNeil's mean assessments of 18 baccalaureate data science programs on the ethical problem-solving criterion with our own scores of spatial data science master's programs. Obviously, the distribution of our rubric scores exhibit more spread and a higher mean value. Since our purpose was not really to compare master's programs in spatial data science with undergraduate programs in data science, we don't draw any conclusions about this. Neither can we compare our scoring tendencies with Oliver and McNeil, other than the fact that in both studies, one researcher performed all the ratings. Here's a graphic summary of the rubric scores we assigned for the spatial data science programs we found. Academic programs are arrayed along the x-axis, ranked from low to high rubric scores. Mean scores per institution appear below. Rows along the y-axis correspond to the 5 criteria that the rubric assesses. On the right, we show mean scores across institutions per criterion. Low means suggest objectives that are not so well served. One clear insight these data reveal is that some master's programs highlight the ethical dimension of spatial data science, while others do so less or not at all. We know a lot of ethics education happens behind the scenes, rather than in the foreground of many academic programs. Still, we agree with Singleton and Ariba-Spell that foregrounding ethical issues in course descriptions and, more importantly, in course content and activities is appropriate for our young field. I'm going to leave this slide up for a moment while I discuss the limitations of our study. One limitation of Oliver and McNeil's approach is that the absence of explicit mentions of ethical issues in course descriptions does not mean that such issues are absent from course content. We proposed a rough understatement factor to account for this mismatch. Another weakness is that the effectiveness of spatial data science ethics education is more important than its pervasiveness. In 2012, May and Luth published a quasi-experimental field study showing that formal ethics education, whether it's embedded within domain subject courses or delivered in standalone ethics courses, can positively affect students' empathy, that is, the ability to take different perspectives, their moral efficacy, that is, confidence in one's ethical abilities, and moral courage, what they describe as the unwavering commitment to carry out tasks in an ethical manner despite potential negative consequences. A comparable analysis of spatial data science education may be worthwhile down the road. In his proposal for Penn State's new master's degree program, Anthony argued that spatial data science is the emergent next step in the evolution of geospatial technologies and methods enabled by big data, including location information, prediction algorithms, and geovisual analytics. Clearly, new ethical challenges are emerging with it, even as the old challenges persist. We believe that students of spatial data science are responsible for identifying, investigating, and responding with integrity to challenges like the ones shown here. We try to convince students that they should aim to master the moral reasoning skills needed to address these challenges, not just the technical skills developed in other courses. For some, that's a hard sell, so we provide options. It's been worthwhile for us to replicate Oliver and McNeil's assessment in the emerging spatial data science domain, if only to incentivize spatial data science instructors and programs to foreground their contributions to ethics education. Furthermore, following Alex Singleton and Danny Arribas-Bell's argument, encouraging geographic and spatial data science educators to prioritize ethical issues strengthens the value proposition of all our academic degrees.